Hi guys, this is Vineet and I welcome you to this video. Today's video topic is numeric data types in SQL Server, and this is part 2 of this video series. If you haven't watched part 1 of this video, please go ahead and do so. It is highly recommended to go in sequence. So watch out part 1 of this numeric data types section so that you can get a better idea of what we are trying to teach in part 2 of this video series. And guys, if you are new to this channel or if you haven't yet subscribed to the channel, I would highly urge you to please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button, it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. And let me give you 5 seconds, please go ahead and subscribe right away. I'm waiting, guys. So guys, I hope you must have subscribed by now. So let me take you to notes quickly. Today we are going to discuss about the float and real data types. I think there will be no demos under this, the float and real data types. But yeah, when we will discuss the int, BigInt, SmallInt, I think we have some demos under them. Yeah, we have a demo under them. But yeah, for this section we are not discussing any demo. We are just discussing this data type, which are float and real data type, and they come under the numeric data types because they deal with numbers. So if we talk about the float and real data types, these are approximate number data types. So remember this word, approximate number data types, and these are basically for use with floating point numeric data. Floating point is basically when we use decimal, although we have decimal and numeric data types to handle decimals, yeah, but we also have these data types to deal with the floating point mathematics or floating point numerical data. And floating point data is basically approximate data, therefore not all values in the data type range can be represented exactly. And the ISO synonym, if we talk about for floating and real data types, is float 24, and basically this is the syntax. Float n is the syntax, where here n is 24. So float n is syntax where n is the number of bits that are used to store the mantissa of the float number in scientific notations. So basically these floating and real data type numbers deal with the scientific numbers, and basically the syntax is float n, where n represents the number of bits that can be used to store the mantissa of the floating point number in the scientific notation, and therefore it dictates the precision and storage size. Now if n is specified, it must be a value between 1 and 53. So maximum value for n can be between 1 and 53. Alright, and the default value of n is 53 if nothing is specified as such for the value of n. By default it takes the value of 53, and here we have a table where it represents the value of n whenever the value of n is from 1 to 24, and the precision is 7 dates basically for the mantissa, and storage bytes required are 4 bytes under these circumstances. And if we talk about if the value of n is from 25 to 53, it requires 15 dates to store the mantissa, and it requires 8 bytes of storage. And SQL Server float and data type complies with the ISO standard for all value from 1 through 53, and synonym for double precision is float 53. So sometimes in some applications we use the double data type. So basically the synonym for double data type is float 53. It can store up to 15 dates and occupies the storage bytes of 8 bytes. And in the below table we have ranges for both the float and real data type. So float ranges from minus 1.79 e plus 308 to minus 2.23 e minus 308, where e represents like 10 to the power 308 here it means, and here it means that minus 2.23 into 10 raised to the power minus 308. So this range to this range and 0 to this range as well, there are two ranges specified, and it depends upon the value of n we are taking to store the mantissa. Depending on the value of n here, it represents what range it will occupy, and For real data type also the ranges are given over here, and it occupies the 4 bytes. So real can also be represented by float, but yeah, we can also declare real as well. Now both the data types have the same notation, like float n we represents the real n as well. So ranges are a little bit different for both, and the float and real are known as the approximate data types. So these are approximate data types. So if we talk about approximate numeric data types, they don't store the exact value specified for many numbers. So remember this thing, they don't store the exact values. They store the close approximation of the value. Now, if we talk about some applications, the tiny difference between the specified value and the stored approximation is not relevant. So for some applications, the difference between the specified value and the stored approximate value is not relevant. For other though, the difference is very important. Now because the approximate nature of the float and real data types don't use these data types when exact numeric behavior is required. So where we want the exact numeric behavior, we do not recommend to use these data types, float and real. Some of the example if I share are that require the precise, let me change this. So some of the example that require precise numeric values are financial or business data, where we need the exact data, not the approximated data, and basically the financial and business data. And if we talk about the operations involving rounding and equality checks, in those cases the exact numeric behavior is required. And in these cases use the integer, decimal, numeric, money or small money data types, and this is recommended. And avoid using the float and real columns in where clause. So we shouldn't be using the float or real columns in the where clause. We should avoid that to search for condition, especially the equal to condition and not equal to condition. And it is best to limit float and real columns to the greater than or less than comparisons. So don't use this for the equal to and not equal to comparison, and can be used for less than or greater than comparisons. Now let's talk about conversion of float and real data. Now the values of float are truncated when they are converted to an integer type. So some of the items from float data type are truncated when they are converted to real data type, not the real data type but the integer data type. And when you want to convert from float and real to the corrected data, so during the integer conversion some of the values get truncated, and if we talk about conversion of float and real to corrected data, using the string function is typically recommended and is more useful than the casting function. The reason is that string function enables more control over formatting, and we will talk about these functions later. Let me see if I can cover, yeah, I can cover this data types in this video. So let's start with int, BigInt, SmallInt and tinyint data types. Let's talk about them. So these are the exact number data types that use the integer data, and to save the space in database, use the smallest data type that can reliably contain all the possible values. If we take an example, for example, tinyint would be sufficient for person age because no one lives more than 255 years. So in those cases tinyint can be used, but tinyint isn't sufficient for storing the building's age, for example, because buildings can be more than 255 years old. Below is the table showing you the exact ranges of number each data type stores. So for BigInt the range is this, and the range expression can be defined like this, and storage for the BigInt is 8 bytes, for integer it's 4 bytes, but the range is a little narrow for the numbers. And SmallInt has the little smallest range, and it requires the 2 byte of storage. And for tiny data types the storage is minimal, storage required is minimal. They can be stored in 1 byte, but the range is very short, from 0 to 255. Now the integer data type is primary integer data type in SQL Server, and the BigInt data type is intended for use when integer require. So BigInt data type can be used in the situations where values might exceed the range that is supported by the int data type. So if we have any values that are beyond this number range for int data type, basically, then yeah, we should be using the BigInt data type to if we have larger numbers to store. Now BigInt fits between small money and integer. Okay, so if we talk about BigInt, it fits between the small money and integer in the data type precedence chart, and we will talk about this chart, the data type precedence chart, later. And functions return BigInt only if the parameter expression is a BigInt data. Remember this. So if your parameter expression is a BigInt data type, then only the function will return the BigInt. SQL Server doesn't automatically promote other integer types to BigInt. Other integer types including tinyint, SmallInt, and integer to the BigInt. So SQL Server does not perform the automatic conversions or promote the integer data types, the other integer data types, to the BigInt type. Only when the parameters are defined with the BigInt data type, then only the function will return the output in the BigInt data type only. Now let's talk about the conversion and parameterization. Now whenever you use the plus, minus, multiply, divide, or modulus arithmetic operators to perform implicit or explicit conversion of int, smallint, tinyint, or BigInt constant values to the float, real, decimal, or numeric data types, the rules that SQL Server applies when calculates the data type and precision of the expression result differ depending upon whether the query is auto-parameterized or not. And we will talk about this concept later. So basically here we are talking about the conversion of integer data types, which are BigInt, SmallInt, integer, and tinyint. If we try to convert these values into other data types like float, real, decimal, and numeric data types, the result of these operations will depend upon whether the query is auto-parameterized. So we will talk about the auto-parameterization of queries later on. But now, for now, consider there is a concept for query called auto-parameterization of query. Therefore, similar expression in queries can sometimes produce different results. And whether a query or when a query isn't auto-parameterized. So here we are talking about the condition when your query is not auto-parameterized. The constant value is first converted into decimal, whose precision is just large enough to hold the value of the constant. Alright, so here we are talking about the situation where your query is not auto-parameterized. In those cases, if we are converting any SmallInt, integer, BigInt, or tinyint value using these operators plus, minus, multiply, divide, and modulus. So when your query isn't auto-parameterized, the constant value will first get converted into a decimal value, and whose precision will be large enough to hold the value of the constant before converting it into the specified data type. So initial conversion is into decimal, then it will get the result gets converted into a specified data type. Let's take an example. The constant value of 1 is converted to a decimal 10, which is the minimum data type required to hold this value, and the constant value 250 is converted into decimal 30 first before it is finally converted into a specified data type. So we talked about a situation where the query is not auto-parameterized. Now let's talk about the situation where the query is auto-parameterized. Now in those cases, what will happen? In those cases, the constant value is automatically converted into decimal 10. So where the query is not auto-parameterized, the initial conversion was into the decimal data type with minimal precision required to hold the value. Whereas in the case where the queries are auto-parameterized, the constant value is always converted to decimal 10 data type before converted into the final data type. And when the division operation is involved, not only can the result type precision differ among similar queries, but the result value can also differ also. And for example, if we take the result value of the auto-parameterized queries, that includes the expression select cast 1.0 divided by 7. So 1.0 is a floating point value, and 7 is the integer value, and we are trying to convert the total expression into float. Now if we take the result of this expression, it differs from the result of the same query that is not auto-parameterized. So if we take the same query in the auto-parameterized and non-auto-parameterized mode, the result will be different. This is we are trying to convey right now. Alright, so we were talking about the result of auto-parameterized queries and non-auto-parameterized queries. For this particular expression, the result will be different because the result of the auto-parameterized queries are truncated to fit into the decimal 10, 0 data type. Alright, now let's talk about the conversion of integer data. Now when integers are implicitly converted into the character data type, if the integer is too large to fit into a character field, SQL Server uses ASCII character 42 or the asterisk. So if conversion does not happen, SQL Server simply uses the ASCII character asterisk. If we are trying to convert an integer value that cannot be fit within the character field. Now integer constants greater than this value are converted into the decimal data type, not the BigInt data type. Alright, and let me explain this with the help of a demo. Give me a minute, guys. So here we are talking about the values that are greater than this value, right? So if we have an integer with any value greater than this value, this gets converted into the decimal data type automatically using the implicit conversion of SQL Server. And these are not converted into BigInt data types. Generally the values greater than this are held by the BigInt data type, but automatically conversion promotes the data type to the decimal data type. So let me take you through an example quickly. So let's trigger out SQL Server, and I will show you that. Let's try to connect to a default instance of SQL Server, and let me trigger a query against any of the databases. You can use system database with that, but ideally we don't recommend you to do so. Ideally you must have some sample database installed against which you trigger a query. In our example, we have installed AdventureWorks 2022. You may install the same by using one of my videos. You can search for my channel for the how to install the Northwind database or how to install the AdventureWorks database. You can search using that. You will get an idea how to install the sample databases. Now let me take an example. We were talking about this. If we are trying to convert the numbers that are greater than this, let's take this, copy out this number. So let me take this number exactly. Don't use commas over here. Take the number as is. So if we try to convert this number, which is the biggest range for the integer data type, and we divide it by 2, and let's take it as result 1 as the column header, and let's take another number. Let's try to paste the same number, and this time I will increase the number a little bit. So we were talking about the numbers that are greater than this number. So let's try to add 2 into it. So make it 649, and let's divide it by 2, and let's take it as result 2. So what we were talking about, if we try to take this number which is greater than this number gets automatically converted into the decimal data type. So yeah, we're talking about it will get converted into a decimal data type. So let's see. If we take this number, it will remain as integer type, but if we use this number which is greater than this number, it will automatically be or implicitly be converted into the decimal data type. We can watch that through the result. So if I execute the query, you see there is a result difference. So we just added 2 to this number, and here the implicit conversion is happening into decimal. That's why we are seeing results like this with the decimal point here, right? And the result 1 is simply the result of this operation where the conversion did not happen, but if the number is greater than this number, conversion happens to the decimal number. So this is what we are trying to convey through this concept. Now let me take you through a demo, and in this demo what we will do, we will create a table using the BigInt data type. We will use various data types. We will create a table using the BigInt, int, SmallInt and tinyint data types, and then we will try to insert the values into each type of column, and we will finally return the data using the select statement. Alright, let's try to keep this video till this demo. In our next video we will try to cover the money and small money data types, so stay in tune. If you have not already subscribed, please go ahead and subscribe to my channel. There's a subscribe button below my video. Please click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. So please go ahead and quickly subscribe so that you shouldn't miss on the next video, which will be the part 3 of this video series, numeric data types. And in the part 3 we will discuss about the money and small money data type. For now, let me continue with this demo where we are creating table using the various data types. So let me rub off this query and let me try to trigger a new query against the AdventureWorks database. Let's trigger a new query over here. So along with me you can write down the code. So I'm writing down the code. We are creating a table in this database. Let me see if we already have a table. So let me drop it if we have my table under. Yeah, we have my table already present. So let me drop this table quickly. I don't need this table at the moment. Let me create it freshly. So let me trigger a new query to create this table. Okay, let's create a table. You can write this code along with me. Create table my table is the table name we are creating. Let's define the structure of this table. Alright guys, let's continue. So we were making the table. Let's take some columns here. So let's take the first column as my BigInt column. We will take this column as so the name of the first column will be BigInt column, and let's take it as BigInt type. This is first column with the BigInt data type. Let's take an integer column, so let's name it my integer column, and let's take it with the integer data type. The next column will be my SmallInt column. Let's take it as SmallInt, and let's take the last column as my tinyint column. Let's take as tinyint data type. Alright, now all the 4 columns are defined. Let's mark this statement complete with the semicolon and put the go statement. So this will be executed as the first batch of statements. The next batch is now starting here. Now what we will do, we will try to insert values into this table. So table name is my table over here. Here we will insert the values. So put values and put the values for these 4 columns for the table which we have defined above. The value we are putting in the first column is the biggest number. So let's put a biggest number 9223373268547758007. So I've taken this big number which is outside of the integer range into the BigInt column. Now let's take the number for the integer column. Let's take it as 2147483 and 647. This is the highest number that can be stored in the integer, and 32767 for SmallInt column. This is the highest range for SmallInt column. And let's take the tinyint column maximum number storage, which is 255 can be the highest number stored in the tinyint data type. So we have taken these 4 numbers over here, and this keyword is not value but values, so put values over here so that we don't get any error messages. So let's mark this statement with a semicolon and go. This will be a second batch of statement, and the third batch of statement, let me write that down. So in the third batch of statements we are selecting these columns, so I can simply take the result separated by comma. Just print the name of the commas. You can copy and paste them down like this, and let's take the last column. Now let's see the output of the result. So okay, I think these should print, and you need to specify the table from which you are printing. So table name here is the dbo.mytable. So let's execute these statements. I hope this should execute. Yeah, these are executed. First the table was created, then the values are inserted, and right now the output is showing over here. This is the BigInt data type column. The value is showing up here. This is my int column, integer type column, and this is the maximum number maximum number that can be stored for this data type. So I've taken the maximum number for each data type, each one representing under a different column data type. Alright, so this is the output, and we are done with this demo. So I hope you like the demo and the content of this video. If you really like the content of this video, please click on the like button. In our next video we will cover the money and small money data types. So stay tuned. Please keep subscribe if you have not already done so. Please go ahead and subscribe right away. Alright, I hope you must have subscribed by now. And guys, if you have huge network of friends, or if you have a good network of friends who are also working in the SQL Server domain, you can pass on or share my video with your friends, and also post in your comments, guys. We really wait for your comments and suggestions regarding my channel and videos. So please do post in your comments whatever you feel like. And also guys, if you would like to contribute to our channel or make some donations to our channel, you can do that so via two ways. There's a topmate.io link given at the bottom of this slide. You can type in the exact link starting with HTTPS and ending in 07 number. So type in this topmate.io link, this link. So basically in the address bar of your browser, if you type this link, it will take you to my topmate.io page where you can make donations and contributions to my channel and to support my work. And there's other way as well. If you want to make payments using the UPI, using the Google Pay or Phone Pay apps, then yeah, you can do that so as well. So on the right hand side, I've given you my Google Pay code on which you can make any contributions or donations to support my channel. I really need your support at this time, guys. So do subscribe to my channel and post in your comments, give in your likes, and also contribute some donations to my channel. And I thank you so much for your time on this video today, guys. And if you want to write back to me, you can write back to my email address, which is given over here, vermavana@gmail.com. You can send in your emails to my email address. And thank you so much for your time on this video today, guys. You have a wonderful day ahead.